All right, welcome to some Venn diagrams, improving independence. And I'm going to talk to you about Venn diagrams first. And I want to tell you that there's a lot of embedded information in these videos, not just about the diagrams, but how the diagrams can help you with probability. And there's also some probability rules hidden in the midst of these slides. So this is a pretty good chunk of information. So Venn diagrams are something used to describe sample sets and relationships between subsets of that sample set. So we're going to just do a quick example. If you had the population of cats, and then they had these particular characteristics, and you also had this population of dogs, and they had these particular characteristics, you would maybe notice that there were several characteristics that were shared by both cats and dogs. And so what a Venn diagram does is it goes ahead and utilizes circles to represent characteristics of sets, and if there are any shared characteristics between the sets, they are placed in what is called the intersection, which is the part that exists in both circles at the same time. So dogs do not say meow and are not independent. Cats do not say woof and are not dependent, but both cats and dogs have these characteristics. So they're both captured in the blue circle for cats and this reddish circle for dogs. And it's called the overlap or the intersection. And we'll talk about notation as we go through that. So here's another example. This is the set of whole numbers less than 13. And they're just scattered all over the place. And then I'm like, okay, well, guess what? I want to create a subset in there of even numbers. So I put all the even numbers in that circle. Notice that the numbers outside of that are still meeting this condition, but they are not even. And then I'm like, oh, but I also want to talk about numbers that are multiples of 3. So it's a separate set of numbers. And so I put those numbers in there, which are 3 and 9. But you will notice that, excuse me, 6 and 12 are also multiples of 3 at the same time as being even. So instead of having blue circles around them in the middle of this other circle, instead I can merge them into a overlap here. So 6 and 12 are intersection between even numbers and multiples of 3. So in terms of how we're going to talk about these, the sample space U is enclosed in the rectangle. So please, you have to have a rectangle to capture your sample space in a Venn diagram. It's required. The circle represents a particular event, and this 8 up here, which appears to be an even number and should be in this red circle. So look at that guy, he's gone now. So this circle represents all the even numbers. So it's a particular event that can happen within your sample space. And anything that's outside of event A is considered being not A. And again, this is the notation for a complement. So if even numbers are event A, the rest of these numbers are outside of that circle, yet still in your entire sample space of numbers less than 13, and they are not A. So that little notation is not A. So here's a Venn diagram talking probability. If you roll a die, you have 6 possible outcomes, a 1, 2, 3, 4, 5, or 6. So this is my sample space, and so this box represents U. And so that's why you've got 1, 2, 3, 4, 5, 6 in the box. And clearly I've already created an event, and that event is event A. This is just the name of it. Sometimes you'll see it written on the outside of the circle instead of on the inside of the circle. So if I just do that, so you kind of see that it's not actually in the part of the sample space of rolling less than a 3. So this is my event, number less than a 3, and that would be 1 and 2, so that is why that's in a circle. And again, this is just set notation. We've seen that before. I already got that. So if I want to talk about notation, if you see this little n outside of a u, that is telling you the number of elements in your entire sample space. So in this case, there are 6 in U. This is the number of outcomes in my event. So there are 2 outcomes. This is a count. This N stands for count or number. So that's not talking about this 2 right there. It is talking about the fact that there are 2 elements in here. This is a probability. So the probability of event A is how many outcomes in the event I'm interested in finding success with out of the total number in the entire sample space. So this isn't any different than what we've talked about. There are 2 numbers in event A. There are 6 numbers in this entire sample space, so 2 out of 6, which reduces to 1 out of 3. So this is probability notation. These are indicating how many numbers or how many values or how many terms there are in each of those particular events. So here's some more notation. This, funny, I always think of this as an E. That literally means that X is in set A. All right, so it's an element that lives in this set. This is the number of elements in set A, and this would be the number of elements in the complement of A, or the number of elements that are not in A. So you see this little markup here. It's referring to not in set A. All right, so now we're going to talk about notation with this overlap. That's a very important part. In intersection, and the word and is very important. And means intersection, and the notation for intersection is this like upside down, well, I guess it's like a horseshoe or an upside down U. That is your intersection, and you can think about it in terms of, if I had to spell intersection, it would be with this letter right there. Oops, I should change the color of that. So intersection has that little thing right in it. All right, and it's the shaded part right there. And so this is indicating that the intersection of A and B are values that are elements in A and simultaneously in B. So again, just getting through some notation with you. And it's the elements that are in common to both sets simultaneously. So the union, and the word or goes with union, so those are going to go together. And if you want to look at the symbol for union, there it is. And again, if I do my little trick, that little symbol looks like this, and that helps me spell the word union. So if you can't remember which shape goes with union or intersection, that one goes for union because it starts union, and the other shape is like the upside down of that goes with intersection. So union means that it's in the set A or set B or both. So everything, union would be everything shaded into this pink guy. And it's important to remember that in this, or means something different. Like if you're talking with your friends and you're going to go to the park or to a movie, it means you're literally going to do one or the other. You're not going to do both. In stats and probability, this or means it could be one or the other, or it could be both at the same time. So disjoint sets is another common term. Disjoint sets are sets that have no elements in common. So in a Venn diagram, there are 2 circles that don't overlap. So very easy to see in a picture. There's nothing in common. They're disjoint, meaning they're not joined together. So kind of this means not, and this means joined. So not joined. There's no overlap. There's nothing in common, which means that the intersection of A and B, if they're disjoint, is the empty set or the null set. There's nothing in it. And another synonym, another word that means the exact same thing as disjoint is mutually exclusive, and they can be interchanged. So disjoint and mutually exclusive mean the exact same thing. They don't have different meanings. So I'm going to give you a quick example on Venn diagram. So this I'm going to use for part A, this I'll use for B. Shade the region representing in A but not in B. So if I want to talk about what's in A, that could be anything in this circle right here, right? That's in A, but I don't want it to be in B, so I can't count this part because that part of A is also in B, so I have to ignore that part. So the part I would be looking at would just be, if I were to shade it in, it would just be this part over here. And if I were going to write about that, I would say, well, that's what's in A, and also not in B. So I put that little not B up there. All right, so neither in A nor B. So I don't want to be in A, and I don't want to be in B, which means this can't be it because that's both A and B. So this one I would be shading everything out here. It's basically all the stuff outside of A and B. There it is, all shaded up. And that would be that if I looked at the union of A and B, that would be everything I have an X in. But I want everything that isn't included in that, so it would be the complement of everything that would be in A and B. So this is everything that's not in A nor in B. All right, you're going to pause the video and you're going to do the same. I've given you the notation, and I want you to pause the video and then shade in the circles as they would be represented. All right, video is on paused. So this is not in A and in B. So not in A literally would be, this is everything that's not in A. I'm just going to put little red dashes on it. So all of that is not A, right? It's outside of A. But I also want it to intersect with that which happens to be B. Well, this is all B. Little dots. So if I want the intersection, I want the overlap. So the part that they both share is the part that has green and red. So this would be the part that was not in A but also in B, and I would ignore the rest. For this one, A intersection B, the complement. So the intersection of A and B would be this part right here. So if this little symbol weren't up here, that's all I would shade in. But I want everything that's not in that X. So everything that's not in that X would be all of this stuff except for that particular overlap. So I would be shading in. Now some of you I know have better artistic skills than me, and so shading may be a little bit neater. But there you go. That's all I've got. All right, so now example, I'm going to do A and B, and you're going to do the rest for try me. So now we've got a Venn diagram. We actually have values in here. So we have 27 people that play both tennis and hockey. Notice that for the total number of people that play tennis, it's everybody in here. So I would have to add those two together to get my tennis people. Same with hockey. I would have to add 27 and 26 because they all play hockey. And these are the people that don't play either. So if I want to know how many people are in the club total, I just have to add all those numbers up. So 15 plus 27 plus 26 plus 7. So if I add all those numbers up, I get 75 people total in the club. And if I want to know just who plays hockey, it's just the ones I put in red. So it'd be 27 plus 26, and 27 plus 26, I believe, is 53, if I'm not mistaken. I think that's right. So now you're going to try C, D, and E. Pause the video, try to answer those. All right, video's on pause. Who play both sports is this 27 in the middle. Wait a second. Yeah, I've got all the answers down here. So 27 is the one in the middle. The number who play neither sport, this is my neither. They're not playing hockey nor tennis. And who play at least one sport, at least one means tennis or hockey or both. So I would have to add up those three numbers right there. And if I wanted to make a probability question out of any of these, I could have, and I would have just made this the denominator because that's how many total are in the club, and I would have put each of my other answers over top of that, which is what we're going to get to here. So we are going to first create a Venn diagram and then answer some questions on this. I'm going to do A and B, and then you're going to do the rest. So I'm going to make a Venn diagram. You might want to follow along. I've got chemistry and physics, so I draw a circle, and I draw another circle, and one of these has to be for physics, and one has to be for chemistry. Now I'm going to start putting some numbers in it. So I always start with this. How many study both? The overlap would be 15, so I could put that 15 in here. And 19 study physics. So this whole physics circle that I'm now doing in green has to add up to 19. So if I've got the 15 already, this piece has to be 4. That's very important. Those have to add up to 19. 17, these have to add up to 17. So that means there can only be 2 people over here in chemistry. And I have 30 people in total. And so right now I have 15 plus 4 is 19, 20, 21, which means that there are 9 people out here that aren't in either of these 2 classes. So this is asking me probability. So that's going to be out of my 30. So both subjects would be right there. I believe that would be 15 people out of 30. So the answer to A would be 15 out of 30, which is a half. B, at least one of the subjects would be one or the other or both. So I'd add all of these up. So 4, 6, so that'd be 21 out of 30, which reduces to 7/10 or 70%. Oops, I guess I'm going to finish these. Probability of being in physics but not chemistry is 4. So part C would be 4 out of 30, which could be reduced as well. I'm running out of time, so I'm zipping through this. Exactly one of the subjects would be either this physics or chemistry, but I would exclude that. So that would be 6 out of 30. And neither subject, that's my guy right here. So E would be 9 out of 30. And you have time to do this pause. And here are your answers for that one. So take a look, and I will go into a little bit more detail on these maybe on the next video, but notice this should not be an E because they called it event A, but these are my blue-eyed kids. These are not, and they're your answers.